Hi, let's solve today's daily challenge, that is perfect squares. In this question, we are given an integer n and we need to return the least number of perfect square numbers. So what is perfect square? They have defined here, but we know what a perfect square is. Basically, consider all the numbers from 1 to n and square them, correct? So those squares we have to use, and we have to return the least number of these squares that sum up to n. All right, so let us understand with this test case, that is n is equal to 12. So it is equal to 12. Now let me write all these perfect squares here. So that is 1 square, 2 square, 3 square, right, so on. So it will be 1, 4, 9, and if I also write 4 square here, it would be 16, 5 square, 25, and so on. Now what I have to do is I have to make this correct. So I can say if I take 1, see, repetition is allowed here, right? If repetition wouldn't be allowed, then there would be cases in which it will be impossible to make up this number, but here repetition is allowed. So that means if repetition is allowed, so one answer is very obvious, that is I can take 1 12 number of times, right? So 1 plus 1 plus 1, how many times? 12 times. So this is a valid answer. Now I have to check for other options as well. Now if I go to 4, then one solution would be to add 4 and add 8 number of ones, right? So 1 plus 1 and 8 times ones would be added. So here total of 12 numbers are used, here total of 9 numbers are used. Let us move to another approach. Let's say I do 4 plus 4 and rest are 1. Okay, so if that is the case, it is 8 and the number of ones we will have is 4 here, right? And we'll be able to make 12. So now these are 6 numbers. Okay, so we are boiling them down. Then we can have 4 plus 4 plus 4. This also gives me an answer, and it is 3. Another option I can use is using 9, right? So 9 plus 4 you can clearly see is 13, so that is greater than n. So obviously this will not be an answer. Now I can do 9 plus, but I can surely add 1. How many number of times? 3 number of times. So 9 plus 1 plus 1. So here we are using 4 numbers. So now if you see, there are no more possibilities here because 16, 25 are already greater than n. So we could only have it played with these 3 numbers, correct? So out of these possibilities, I have to return the least number of numbers that we have used, the number of squares that we have used, and that is 3. So this will be the answer in this case. So now I hope you have understood what the question is asking us to do. Right now, from this you can clearly see that we have to consider all of the possibilities, and when we have to consider all of the possibilities, one solution is very clear to us, that is recursion. Now another reason recursion would be coming to our mind in this problem is because, now see, what are we doing? We are only checking minimum number, right? So let's say I do 12 minus 4, right? So I have 8. So can I say that 1 plus whatever be the number of minimum operations I have to do for 8, right? Minimum number of squares that I have to add, 8 that I can add, and I will get an answer, correct? So that means there are sub problems that we can solve, so thus we can use recursion here. All right, so that would be our very first solution. Now again, let me first draw the recursion tree for you, all right? Okay, so here is the recursion tree, right? So what are we going to do? We are taking this n and then we are going to iterate in all these perfect squares. Now the limit would be to iterate in it is, let's say this is I, right? What integer that I have to consider? So I into I, right? It should be less than equal to this number in n, right? Only then we will be able to take these squares, right? Other squares we don't have to iterate for them because they are already bigger than this number. So how will they help us to solve this question, right? So we would iterate in these number of possibilities, that is root 10 times we have to iterate. Now here n is 12, so I can consider only 1, 4 and 9. And then if I consider 1, what will happen? N will become 11. And if I consider 4, what will happen? N will become 8. If I consider 9, n will become 3, right? And if you keep doing so on and so on, so here in the recursion tree, whenever your n becomes 0, right, you know this, I have got an answer, right? So whenever n becomes 0, so this will be the base condition for our recursion. As soon as n becomes 0, you have to store the number of steps that you had to go down the tree, and store it, let's say, in our answer variable, and keep calculating the minimum after doing these recursive calls, right? So this is basically how you have to do recursion, right? Let me also quickly show you the code for this. So here you can see the code. All right, so we are using recursion here, and what are we doing? We are using this function, right? So this function is a recursive function, and we are only taking one parameter, that is n, and then we are checking, this is the base condition, if it is less than equal to 0, then return 0, because we have already done all kinds of operations. Okay, and if and all right, and then what we have to do, we have to store answer is equal to n, because see, maximum number would be n only, right? So instead of storing int max, we can store n, right? Because it's also a valid answer, that is by using one n number of times, correct? Then that is also an answer. So, and that is the maximum value. The values, then if you consider other squares, it will only be decreased, right? So after we initiate our answer variable, then we will simply iterate how many times from I is equal to 1 to I into I less than equal to n, basically root in number of times, and then we will be calculating that particular square value, whether in this case it is 149, right? For these three values we have to iterate. So we'll calculate this here, and then we will calculate the answer. How? First we will take whatever was the minimum value, right? Whatever was the previous answer value, and then we would do 1 plus, right? Why 1 plus? Because we are considering this number, right? We are considering if this is a possible answer, so we have to include this number, this particular square that we are using, 1 and 1, so that is 1 square, right? And then we are recursively calling for n minus a square, right? So that you can also see from here, what are we doing? We are iterating for these, and then we are taking, let's say if I take this square, then what I have to do, I have to take this step also, right? So this step is 1, so 1 plus I will call for 12 minus this square, which is 11, right? So I will call for what is the minimum number of steps for 11, please return me that, and then 1 plus the minimum to get this number, and that will return as an answer, right? So I hope you are understanding, and then after the end we have to simply return answer. So this is basically the recursive solution. Now for the time complexity of this recursive solution, we can already see, first of all, what we are doing, we are iterating here how many number of times, root n number of times, and then how many times this recursion would happen. At most it can happen n number of times. Why? Because I know one can be a possible answer and it is a repetition, so I can have n number of ones to form this integer n, right? So at most n recursion calls will be there, right? So it will become root n power n, right? So that will be the time complexity for this, right? That is basically n raised power n by 2. Now let us come on the board, and obviously the solution will give me TLE, right? So I need to optimize it. How am I going to optimize it? Whenever I have a recursive solution, I know I have to check if dynamic programming is possible, right? So one thing is clear, we have sub problems, correct? But do we have overlapping sub problems? So that we have to check. Now you can clearly see we definitely have overlapping sub problems, and that you can see from here, right? Let me take a different pen. Let's take green. So here n is equal to 3 is present, here n is equal to 3 is there, here n is equal to 2 is present, let me find another 2, here n is equal to 2, and yeah, here n is equal to 2. So there are many overlapping sub problems. So if I've already calculated for n is equal to 3, why do I need to again make recursive calls here and calculate it? So now here I can simply do my DP, right? So if I look at the code for the recursion, I can see that this part has to be common in the DP as well, right? So I have to check for all these values, right, if an answer is possible. And instead of ans, right? See, here doing top to bottom DP is very easy, right? I'm going to discuss bottom up DP. All right. So essentially, what we will do, we will make our DP array, right? And first thing to note here is that it is only one integer that is changing, right? Only one value that is changing. So it is 1D DP. So I have to only take, okay, wait. So I have to only take one array, and this is my DP array. What should be the size of this DP array? Because I have to return an answer for n integer, right? So my DP of I will represent for that I integer what is the minimum number of squares required, right? So if I for n is equal to 12, my DP array size should be n plus 1, right? So it is 0 1 2 3 4 5 6 8 9 10 11 and 12. This will be my DP array. And what does DP of I denote? DP of I denotes for this particular value how many, what is the least number of squares that I require, right? Okay, so now it is clear what DP of I is going to represent and what should be the size of DP array. Now what should be the base condition, right? The base condition is here in the recursion you can see it was n less than equal to 0, but obviously we don't really have to calculate for n less than equal to 0, but for n is equal to 0 I can surely put here an answer which will be 0, right? So there is only one initialization, that is DP of 0 will be 0, because I have to make 0 and 0 can be made using 0 only, 0 number of squares, correct? So this is formed. Now I will iterate from here, okay? And I will iterate in these possibilities, right? I less than equal to n, these number of possibilities. So first I'll be iterating like this. So for DP of 1, what should be the answer? So I have only one possibility, that is 1 here, right? So I can only use this, and I can already see the minimum required square is 1 only here. So we'll insert 1. Then we will come at this 2, right? We have to form what will be here. So what do we have to do? Again, consider all the possibilities for this case. Again, we only have one, right? And if you try to explore the possibilities, then there is only one possibility, 1 plus 1. So here you have to insert 2, then you will come at 3. Now at 3, again, you have only 1, right? You cannot use 4. So again, it will be filled with 3. Now, whenever you, when you come at 4, now you have two possibilities considering 4 or 1. How will you fill this? So you will basically fill this. So let me write here, DP of I is supposed to be minimum of, right? DP of I, comma, 1 plus, that is you're taking a number, plus DP of I minus, remove that square, all right? And this minimum value we have to calculate. Now here at 4, initially all these values will be filled with 0, okay? Now initially it will be 0, but we have to initialize it with the maximum number, right? So before looping for this, we will do what? We will take DP of I is equal to I for initializing it with the maximum value, and then we will be here, right? So we don't have to fill them with 0. It's actually that number itself that can be the maximum, right? Very sorry for that. All right, now we have DP of I is equal to I, and then what we'll do, we'll start iterating for the possibilities. So here we have two possibilities, that is using 1 or 4. So what you will do, you will calculate minimum of DP of I, 1 plus I minus square. So if it is 1, right? So 4 minus 1, if you do, you will come at this index. So 3 plus 1, right? And 4 comma 3 plus 1 is 4, right? So still the minimum is 4. Then if you consider 4 here, right, that is the second possibilities, then we have 4 comma minimum of I minus square, that is 0. So you come to this index, right? So you add 0 plus 1, which is 1. So this is the minimum required number. Then you will come at 5 and you will do the similar thing, and this way you will keep filling the array, and you will have to return DP of n as an answer, because it is the an integer that you want the least number of squares for, right? So this will be my answer. So this is basically how we have to do DP, and this is bottom of DP. So let me go and quickly code it out. Okay, before we code it out, let me discuss the time complexity of it. So what we will be doing is first iterating from all the values from 1 up till n number, right? First we initialize dp of 0 as 0, then iterate from I is equal to 1 to n, right? And then it is similar to this, right? Explore all the possibilities and store it. And only difference is this is also same, that is dp of I should be I, and this will become dp of I, this will become dp of I, and this will become dp of I minus the particular square number we are at. Okay, now let me go and quickly code this up. Okay, sorry, I was discussing the time complexity. So for I up to root n, and let's say inner loop will be from j is equal to 1, that is explore all the possibilities up to root n. From recursion we know we have to go up to root n only, because all the values after root n are of no use to us, correct? So this will be operating up to root n number of times, and this for n number of times. So the total time complexity becomes n root n, right? And space complexity will become big O of n, because we are using the dp array. Now let us go and code this up, right? So let me do the very first thing, that is declare my dp array. All right, and it will be n plus 1 size, and initially I'll keep every value as 0, and I'll explicitly write here, although at 0 index we already have 0 value, but dp of 0 should be 0. This represents our base condition of the recursion. Now I'll start iterating. As I said, iterate from int I is equal to 1, I less than equal to n, and I plus plus. Then do what? Initialize dp of I with the maximum value. The maximum value can be I, that integer itself. And then we'll iterate in int j is equal to 1, all the possibilities. And the possibilities exist up to root n, right? So j into j less than equal to n, and we have to simply do j plus plus here. After that, the whole thing is same as that of recursion. So we'll first calculate int square, and the square will be j into j this time, and we have to calculate. Okay, we can only see here we are dealing with index, right? So if, to make sure that we don't go out of bounds, we have to check if I minus a square value is in bounds, right? That it should not be less than 0, correct? So I will simply check I minus a square should be greater than or equal to 0. Only then we have to calculate dp of I, right? Which is minimum of the previous value, and 1 plus, if we consider this square, what is the minimum number? So that we will get from I minus if we remove this square from this. Alright, so that is the whole logic for it. And let me quickly go and return dp of n here, right? So that is the whole thing. And now let us run this. So it's accepted. So this is basically how you have to solve this question.